Hello everyone, today is still 12 June and I decided to make a little brief video about some anatomical points just in order to help myself to better remember it. Because today, during these 3 days, I learned about one very interesting thing, which I once I'm already learned about it, but not so deeply right now. And I'm just decided to make this video, just trying to make these videos in order to repeat all the things which I learned today. I know that no one will watch this video. It's just for me. Yes. Okay, what I learned today and several days ago, I learned about nucleus or basal nucleus of Meynert. It's a nucleus which is situated. Maybe I need to use this shames. Actually, this shames might much better for this. Okay. Anyway, we have under our basal ganglia, we have such a structure like substantia innominata or innominata. I don't know exact pronunciation because I never heard it before. But substantia innominata approximately lies under the anterior thalamus and maybe posterior portion of pallidum and putamen. And within the substantia innominata, it's a thin layer of gray matter consisting of 3 layers. I don't know exactly all those layers and all those connections. It's difficult, but I'm learning deeply about basal nucleus of Meynert, which located exactly in this lamina, is this substantia innominata. It's like part really because this nucleus also pretty thin and pretty wider spread, like some lamina. And this nucleus contains cholinergic projections, and this nucleus is very interesting only because of its single major source of cholinergic projections to the almost or maybe completely all cortical areas. It's not joke. It's really so. I learned about it, and I'm read about it exactly, and it's really so. Maybe it sounds strange. I don't know. And this nucleus contains, we might separate this nucleus into 3 regions: anterior region, intermediate regions, and posterior region. And we might subdivide these regions into some subnuclei. Anterior, I have some troubles with the sounds. I can pronounce this more greatly, but when I will make this pronunciation like maybe a little bit similar to your pronunciation. It's so shame for me to talk in this way, but sometimes I'm talking and it's like I love it. I'm just afraid, literally afraid to show it for other people, really, especially people from my surroundings or people which surround me. It's true, but let's continue. Anterior part we might subdivide into anteromedial part and anterolateral part. And in internal part we might subdivide into interodorsal part and interoventral part. And posterior part we not subdivide. And actually it's explanation about anatomy of primate macaque's brain, if I'm not mistaken. And in humans we also have subdivisions between anterior part, and internal part. It's subdivisions like maybe antero-intermediate part. Yes, it's anatomical points. And regardless white matter tract, we have 3 massive bundles of white matter which connect these subnuclei with cortical areas. And from medial side we have 1 bundle, and from lateral side we have 2 bundles. Maybe it's not important, but I just decided to learn about it. And I cannot describe about all exact connections because today I made beautiful shame, and in this shame which lies here, I'm right about all those exact projections. But nucleus basalis of mine is very interesting because it projects to the cortical areas. It's a cholinergic nucleus. Actually, it has another neurotransmitters or neuromodulators, but mostly it's cholinergic, of course. 90% of magnocellular cells, if I'm not mistaken. And this when it's going to be enter cortex, these projections from this nucleus, these axons, I exactly don't know, unfortunately, where or which layer it goes. I suppose it goes to the layer 4, pyramidal neurons, maybe for layer first and second layer, which associative layers mostly, which take place for two fibers, if I'm not mistaken, because I'm not learning about it briefly. Oh, sorry, completely. I will do this in the future. And just very interesting point that these fibers enter cortex and they has connections to the neurons, to the microglia and astrocytes, very important connections, and direct connection to the very tiny capillaries, maybe, if I'm not mistaken, yes, capillaries. And it were, if I'm not mistaken, it works in such a way that acetylcholine synthesized from these ending and terminals goes to the bloodstream within these capillaries and then this binds to the receptors which situated in the endothelium layer, and then these receptors, I don't know which receptors, maybe nicotinic, which is ionotropic, and this is always going to be excitatory receptors, or maybe muscarinic type 2 or 4, which inhibitory, and type 1, 3, and 5 is excitatory. It's a G protein coupled receptors. And eventually, these endothelial cells activated. It's not correct, I know, but eventually it's make nitric oxide, and this nitric oxide works in ways that it's just ways to dilate vessels in the brain and in the periphery as well. And when it's gonna be ways of dilation within the cortex, cortex resume more blood supply, and it's one point why acetylcholine is so important for cortex, really. And also acetylcholine very important for neurons, but I don't know how exactly it works. I know about some either theory or maybe not theory, something else that how it might work with again occipital cortex, which is responsible for visual processing. If I'm not mistaken, again, based on nucleus of Meynert, stand projections, maybe from posterior subnuclei or from internal. Maybe internal is actually the most BJ subdivision of this nucleus, and it's my stand projection to the occipital cortex, if I'm not mistaken, to the striatal, no, not striatal, primary visual cortex, Brodmann area 17, if I'm not mistaken. Again, I use this word pretty often, and it has two types of projections: direct projection and indirect, if I'm not mistaken. Again, it's like theory, but it's like theory, but it's very interesting. Direct projections goes to the first and second layer, and it has on the postsynaptic terminus, of course, it has muscarinic receptors type 2 and 4 inhibitor receptors, and it has collaterals to the 4 layer, which is responsible. It's if I'm not mistaken, again, it's a pyramidal neurons, which its main neurons which receive direct input from our eyes, from retinal ganglion cells, and not only ganglion cells, of course, but mostly. And it's working in a very interesting way. When we stimulate basal nucleus of Meynert, it sends high energy projections to these two projections, and when it's activate, and it's activate 4 layer because 4 layer contains nicotinic receptors, which is excitatory, and it's simultaneously suppressed first and second layers, which has muscarinic type 2 and 4 receptors, which inhibitory, and it works for some reasons that when we perceive information, for us it's very important to perceive it briefly without some without some blockers or some problems, and this nucleus accelerate 4 layer, which is responsible for direct perception of this world, and suppress second first and second layers, which are responsible for not direct perception of this word information for this word, but from associated projections from other cortical areas, because direct projections are responsible for perception of the word, and association cortical projections from other cortical areas responsible for not perception, but for maybe not just imagination, but it's responsible for perceiving information which encoded by the brain. And I'm a little bit confused. Sorry, I just isn't made some preparation for it. I'm just trying to discuss about it as I can. But I mean that these cortical areas, again, I will try to do this. These cortical areas responsible for calculating maybe information which processes in another brain areas. It's a way how what brain think that happens inside of us. I hope I'm correct. Sorry, I know that no one will watch this video. Maybe once, if it's going to be possible, if someone will support me and will become my subscriber, I promise that I will learn about it completely, and I will discuss about like crazy details like never and no one before. I promise, because I can. Because in order to make this video, I made no any preparations. I'm just trying to talk with my knowledge, with my ability, because in real life I cannot talk to other people in English especially. And the main way how to train my vocal cords and train my ability to talk in English is video makings and some audio records, of course. I made some audio records, but not too much. From time to time, maybe once a week or twice a week. But it's pretty beneficial, really. For me, it's very beneficial. Okay, in this video, I'm trying to discuss about nucleus of Meynert. It's very juicy. Actually, it's only, or not only, it's very brief explanation, because this nucleus just it's the main source of cholinergic projection to the cortex. We have 4 major cholinergic sources in our brain. Basal nucleus of Meynert projects to the cortical areas. Medial septal area or nuclei project to the hippocampus via fornix, and its major source of acetylcholine to the hippocampus. And two nuclei which lies in the pons in the brainstem. Peduncopontine nucleus, which lies a little bit superior, and the lateral dorsal tegmental nucleus. This nuclei are responsible for supplying some brainstem nuclei, and also, if I'm not mistaken, peduncopontine nucleus, very important cholinergic source to the some nuclei within the thalamus. Maybe not only thalamus. Okay, it's all what I would like to discuss today. I so dream to talk about it for my auditorium, really. Now I'm staying here, and really, because sometimes I think that no one never in any situation, any case, if it's gonna be it doesn't matter if it's gonna be either it's gonna be bad quality or bad quality or good quality. Anyway, no one gonna watch my videos maybe because it's the way how my brain works. But if it's not gonna be so, please subscribe me and just support me, because I'm very needs in it. Actually, no, now it's useless to talk about it because no one will watch this again, of course. Anyway, maybe once much later someone will watch this, I don't know. But just thank you very much, and goodbye.